So we're gonna have some pretty neat stuff. All right,
That's
check
pretty
this
rad.
out. This is a brain scanner. So this thing actually puts on your head, and then it picks up your brain waves using this. And then I've modified it using an Arduino. And then you hook this part up to a computer, and we can literally read your brain waves, yo. So we can take this, or we can get an idea of all of your brain waves, and we can kick them out. I think I made, what is it, Dan? Didn't we make you wear this, Dan?
I was just going to say, we legitimately made Dan do this, and it was crazy.
Yeah, right? It was
he has
so
no
super
brain.
cool.
I mean,
So just keep that in mind for all the people that are like, hey, Mr. Willett talks a lot, but does he actually deliver? This is one of those times I delivered.
The headlamp.
Mm-hmm. Ooh, maybe I should mount some LEDs on it so that way they kind of like sparkle while you're doing it, just to like have fun. Oh, it'll be so cool.
Different colors.
All right.
Moods.
Oh, that would be cool. Like a fancy mood ring, right?
Yeah. You know, when you're talking like this, it reminds me of the guy from Powerpuff Girls, the scientist.
That's basically who he is.
Device like that.
My Powerpuff knowledge is about this much, especially compared to like My Little Pony. I've got like you can't even measure that one there.
I haven't seen it since I was like 4, but.
Oh, I gotcha.
Well, I'm fairly certain it was a compliment.
Oh, there you go. Well, I like that.
I mean, he was a mad scientist, so.
That's all right. Sometimes you walk that line between genius and insanity a lot. So that's legitimately true, people. Just in case you don't know that. So
is that your justification for whatever?
Right. Yeah, actually, I justify a lot of stuff.
Smart people are insane.
All right, let's see how many people we got here. Holy cow, we got a lot of people. I didn't even realize we're part of the conversation. Hi, everybody. Looks like we got, what, is everybody here?
We have 10 students right now. I think we have 13 actually in the class.
Okay.
Well,
that's probably all for today, though. Is that right, John? If maybe you know.
We're messaging a few people, but I think we should probably go ahead.
Okay. Hey, so John's got a poll that I would like you guys to go ahead and give a look at. And what this is I've got 3 paths set up. I've got one that's associated with space. I've got one that's associated kind of like with plants and kind of like growing things and stuff like that. And then I have one that's kind of associated with like earthquakes and natural disasters. And so if you could go ahead and vote on what you're interested in, then we can kind of like get an idea as to where we're going to go. And really we can do a couple of things with this stuff. We don't necessarily have to like, just because you pick one doesn't mean that we can't bring in elements of the others. And in fact, I probably will. So depending on what the breakdown of the class is, we can kind of get an idea of what you guys are after. And so
I think only one person hasn't voted.
Yeah, so if you haven't voted,
look at Earthquakes getting some votes, though. Okay.
Yeah,
I'm super into it.
I'm like, that's pretty cool.
The first group that did the runaway plant vote, I mean, like, plants are cool, but to win in a shutout was kind of weird.
Well, yeah, especially with, like, earthquakes in space. That was kind of
I think that says a lot about level 3.
Yeah.
Just want to grow my plants.
Yeah, you're like, what kind of plants are you interested in? And I was like, you don't have to answer that question.
All kinds of plants.
If your answer...
Yeah, maybe they're a little bit older, so maybe they're from the Farmville era, and this is
don't even bring up Farmville.
No, too soon. Too soon. Yeah, my bad.
My plants are all dead. haven't done that in a long time.
We still have one person who hasn't voted, and it makes a difference.
It does. Oh my gosh, so much difference. Like for real. Like if you haven't voted,
I can't tell who it is,
all the
but
pressure's
do
on
it.
you. Just do it.
Was it Malik? Okay, Malachi, just type what you want your vote to be. It's not popping up for him. He votes space.
Space.
So,
okay.
There it is.
Looks like we got some space. Space is going to be where we're at. So, okay. Are you holding a dog? Holding a dog, aren't you? It knew that we were talking about it. It was like, what? What's up?
I've never seen that dog, Ray, and I love it.
So I've got a couple of pets. Hey, just so as a heads up on this, you might hear Bob. Bob is my cockatiel, and he's literally right there. He's kind of covered up for right now, but he likes to participate sometimes, and so he'll be like, caw, caw. Like, I mean, not really like that, but you get what I mean. It's going to sound like a bird. And then I also have a cat that's running around, and his little space is right there. So sometimes he'll jump up, and he'll be like licking his paws and stuff like that in the middle of class. So I also have a couple of children that are running around the house. My house is kind of small, so I've got this camera set up with the whole like pinhole thing to kind of break it up, so that way I have a whole bunch of people that are like doing their things while I'm also doing my thing. Somebody else got a cockatiel. Oh, did you hear him? Yeah, there he is. Maybe we could like get them to talk to each other. That'd be kind of cool. But anyway, all right. So, I can't wait to get a dog. I want to get a dog. I want to get a big dog, but like big dog, like not.
Is it going to fit?
I don't know. We'll have to wait. We'll have to see. We'll have to see. We might be getting a new place, so we'll have to get a new place with a new dog. So that'd be kind of cool. So yeah. Anyway, all right, people. Are you ready for this? Are you ready for the journey of a lifetime as we're getting ready to go forward through Upward Bound 2020 summer? So how many of you guys have had me in class before? How many of you guys, if you could throw up a reaction, if you could give me like a thumbs up or like a clap or something like that on your screen, you know, if you could hit that reaction button, there's a little button down here. It's got a little reaction. You got that there. There we go. Like, give it a shot. If you haven't seen those, they're down at the bottom. It should be like a little smiley face with like a plus symbol next to it. If you click on it, it can give me like instant feedback, that type of thing. And it's like cartoonish, so that way it's easy for me to recognize. So it looks like I've got some people in here that I haven't had before.
I actually think only Malachi and Alyssa were here last year.
Cool.
You have a lot of new people.
And then I don't think we did space last year either, did we? Did we do other stuff? I can't remember what we did. I don't know.
We did a little bit of all three.
A little bit of all three. Okay.
Well
then,
science.
You did. All right. Well, we'll get to some cool stuff. So, hey, just as a little bit of a rundown. All right. So my name is Andrew Willett. I teach biology classes out at Neosho County Community College, and I teach like everything from like general biology to majors biology to the cadaver lab. So I'm in charge of the cadaver lab. So human dissection class. I even got a class on human dissection. And I've got, my specialty is biochemistry and biophysics, but I love space. I love science. I love all this stuff. And tech is like really like kind of my thing. I like to play around a lot with that. So we're going to be taking a look at some interesting things throughout the summer. And since you guys selected the space track, we're going to have to take a look. I'm going to have some stuff that we're going to be pulling up that we can do some fun interactives. And I've got some stuff planned out, some different things. And I've actually got kind of like my own little connection with the space stuff, because I've actually had a couple of uncles that worked for NASA. And so my uncle John used to work as an engineer at NASA. And I've actually got like a whole bunch of the his actual like NASA pins that are associated with like various different things that he's done at the, so like his 5-year pin, his 10-year pin, his 30-year pin, all this stuff. And I've got lots of like NASA memorabilia and just different like patches and all kinds of stuff like that from the space program. So he specialized in satellite communications. So this is actually my uncle, and he did a lot of fun stuff. He actually got us an Atari computer when I was like your guys' age, but nobody in my family really knew what a computer was. And so like the only thing that I used it for was like running games. And so I like to think about how different my life would be if I would have just ran with that and been like a programmer full time for like the rest of my life, how crazy that would be. So I like space, and I like answering the questions about space. So some of the big questions about space that we have are, is there life out there? Is there intelligent life? Is there just regular life? And that actually falls into a field of biology, because biology is the study of life. Hey, what's up, little dude? Hi. So we actually falls into this field of biology called astrobiology. And that questions, those two major questions that I just kind of proposed to you, those are the field, that's what we're trying to find. Is there life outside of the planet? And then the other one is, if there isn't and life is only on Earth, where did it come from? And how is it evolving? So astrobiology is actually pretty cool. And one of the neatest things about that is that as time goes on, we are finding more and more and more exoplanets. So if you guys have never heard of an exoplanet before, it's a planet that is going to be around a star and is similar to like what we have. Not all exoplanets are similar to what we have for Earth, but we found a large percentage of them that are. And so eventually, if you're an astrobiologist and we do have life that's found on another planet, there's going to be a big explosion for astrobiologist jobs because you're going to be in high demand. So you're going to be looking for, what is life like? What does that mean? What kind of systems? Do they have the same systems as us? It's like a whole new world of exploration. And so space is kind of cool. We'll be taking a look at it. You might have been getting some of the space questions. You might have hit those tests. So the test that you should have taken already, and if you haven't, I think you're still capable of taking it. But it should have been 3 parts, and it should have been 3 questions each. What we're going to do is that was kind of the pre-test. And so at the end of the semester, what we're going to do is I'm going to have you take the full test for one of those particular sections. So I'm going to look at your pre-test, and then I'll look at your overall after that. So you've got tests at the end of this, at the end of the semester, and you've got some tests at the beginning. How it's going to work for us is every week I'm going to basically be assigning a little bit of work for you guys to do and some information to kind of check out. And then what's going to happen is that when we get back into the classroom, we're going to discuss a little bit about what you found, and then we'll have like a topic for the week, and then we'll have some kind of little bit of like a classroom activity, and then I'll give you like another virtual lab or some stuff to explore to kind of like pull some stuff together to do some things. And so that's the general overall flow. So you should expect to have a little bit of homework every week. I've got a virtual lab for you this week that I'm going to be walking you guys through. And we can actually go ahead and we'll start with that. So let me pull over here. Let me see. Here. So let me pull this up. So let me see. So this is going to be, let me go ahead and put this in your class, science. No, your science 1, my bad. Science 1. Let me go to classwork. Create. Give you your stars virtual lab. And then we'll say, fill in the table and answer the questions. All right. We'll make this worth 1 million points. Is that 1 million? 1, 2, 3, 4, 5, 6. There you go. And then topic we'll say is week 1 homework. We'll give it a due date of this upcoming Friday. And then I'm going to go here and add. Stars and galaxies. And then I'll say make a copy for each student. And then I'm going to assign. I love the fact that you can assign it to all the classes or just one of the classes. Oh my gosh, it's so nice.
That's really helpful.
It super is. So now you should have this. It should be available in your classwork. So you should have STARS Virtual Lab, and everybody should have their own copy. So we're going to be working on that. And what we're going to be doing, let me pull it up here. So this is kind of like what you should see. And I'm actually going to get rid of this because this is blank on your guys' stuff. So you should have something that looks like this. And actually, maybe it won't be since it auto saves. We'll see. A might already be done for you. So we'll have to see how that goes. But when you click on this link here, this is actually the link for the virtual lab. Now, I believe Adrian's going to help us out. And the thing is that, did you guys notice that when I loaded this, it was like a real quick, like it flashed, like it almost looked like a puzzle piece. So some of these labs that we're going to be doing at the beginning of the semester are going to be heavily reliant on Flash. So Adobe Flash is going to be the primary driver behind a lot of the stuff that we do. The problem with that is that Adobe Flash is like no longer going to be supported come around in December. And really Flash has kind of got a lot of vulnerabilities anyway. So a lot of browsers do not have it enabled at the beginning. So you actually have to tell your browser that you're going to allow Flash to run. Now, a lot of times what you'll do is it'll actually load like what looks to be a puzzle piece, and it will have instructions. A lot of times people just say, oh, it's broken, it's not going to work for me, without actually reading what it says. So it'll be like a puzzle piece that shows up, and then it'll have instructions that literally say like, you know, click to enable, or click, you have to modify in your settings, or it'll say something like Flash is blocked. A lot of times for your browser, you'll be able to click up in here. There'll be like a little puzzle piece with like an exclamation point, or there'll be an error message up here that you can actually click that will allow you to go into your settings to let Flash run. So it should be disabled by default. And when you enable it in your settings, it should basically ask you if you want to allow this to run. So what you'll do is you click on the link, it will take you here. And a lot of times you'll see that puzzle piece and it will say, click to allow Flash to run. So I believe Adrian has got us a nice little video. So if you need help when it comes to, yes, homework assignment 1, enable audio Adobe Flash Player in your Chrome browser. So there's some instructions on how to do that. And yes, John, to everybody, if you need help, stick around at the end of the meeting and we can kind of help walk you through, because we're not going to be here for exactly the whole time. So Savannah cats, nice. Cockatiel. All right. Everybody's got pets. Seems like everybody's got pets. I didn't have a lot of pets for a long time, and then my house exploded with pets. So let's see here. I've got pets and I've got hot peppers. Maybe what we can do is we can have a competition between the 3 upward bound classes, and the classes that have the best scores overall get a pick which upward bound instructor or upward bound member eats one of my hot peppers on a live stream. And we can have like a hot pepper challenge, like amongst the individuals, because I'm growing ghost peppers. I'm growing Carolina Reapers. I'm growing Scotch bonnets. I'm growing some fatales, and I'm growing some scorpions. I got like 3 or 4 different scorpion varieties that are out there. So, oh boy, it's going to be a hot summer. So,
has allergies, they can just take one of those.
Yeah. Oh yeah. It's going to be really funny. You know, John told me that he was looking forward to doing something like this. So I think he volunteers, and I know Daniel would volunteer for it. So we'll get everybody, and Brad.
That's what I heard. Yeah.
I'll have to dry them out and ship them. And then that way, like everybody will just have to take them at the same time. We can have the hot pepper challenge for the class that does the best. It's like, do the best so you can see us hurt ourselves on camera. That's what you're. So anyway. So yeah, we'll see if we can't do some hot pepper challenge. But anyway, so as we're working with this, you should see this is kind of the virtual lab. So I've kind of filled out some of this information for you. We've got this first table here, and you'll notice that this kind of matches up. If you click on the journal part, it'll give you questions. Now, I kind of took some of these questions and I modified them. You don't have to do these journal questions. And if you come here to the table in the graph, you'll see you've got this information that's, you know, this is what they want you to fill out. The problem is that I've got no way of you actually printing this information and stuff like that. So don't use this when you're doing the virtual lab. What I need you to do is that I want you to use the spreadsheet that I've made for you. So I basically replicated the table, and I've given you some information here. So elements present, these are the options that you have. So if we go here to the stars and the galaxies, what we're going to see is you've got this area right here, and then I've duplicated the table in the graph, and I've taken some of the questions, and I've put them into this spreadsheet for you. So this is actually what you've been assigned, so this is what you're going to use to fill it out. So that way, if you have to restart this or whatever, it's all saved on the Google Docs, so you're not going to lose anything. I highly recommend you use Google Docs for pretty much as you can, because you cannot lose it. It will save it up in the cloud for you. It would be real good. So let's start it off. Okay, so what we're going to be looking at today is we're going to be looking at some spectra data. So spectra data is really super cool because you guys ever go outside and look at the stars? Or are you guys all asleep by the time it gets dark? You guys asleep in bed? Yeah, Malachi's in bed. What, 7:30? 7:30 your bedtime? So sometimes my children, I'm putting my kids to bed. My kid's bedtime, his bedtime is 8:30 is when we try to get him in bed. And now that it's summertime, he's literally like, it's light outside. And I'm just like, too bad, go to bed. It's time for you to go to sleep. So when you got the stars that are outside, right, they all look roughly the same. They all, I mean, some of them a little brighter, some of them a little darker, you know, some little twinkly, a little bit different and stuff like that. But they're all stars and they're all shedding light, right? So those photons that are getting emitted from those stars are traveling billions of miles in some cases, right? Trillions of miles in some cases before that photon actually makes it through the Earth's atmosphere, hits your eye, and then it ends its life, if you want to think about it. Photons aren't really alive, but let's give it some human qualities here. So the photon, boom, hits your eye, and now it's absorbed, and you perceive that as being a twinkle on a star. If we take a telescope and we focus that telescope only around the area or the light coming off of one of those stars, we can actually collect spectrum data. So what we're going to be looking at is some emission lines, some of the spectra data that we get off of the light that's emitted from some of these stars. So let me pull up this first star here. Now this is pretty cool. These spectral lines, they correlate with the elements that the star is made up of. So if I come down here to the element table and I pull up calcium, we're going to see these different lines that represent calcium. If I come down here to helium, they're a little bit different. Hydrogen. So what you should be seeing is that every element has its own fingerprint as to what emission lines it has. And what we can do is we can actually compare the light that we get from a star with the known spectra that we have for the elements, and we can actually then tell what that star is made of just by looking at the light. So take, for example, for this first star, for A, I'm going to start with calcium. I'm going to grab this bar over here, and I'm going to slide it over. Do those look like they match up? Yeah, pretty close. What about these? Yeah, yeah, yeah. Yeah. So this star looks like it's got calcium in it. Let's look at hydrogen, or let's look at helium. What do you think? Do you think that this star's got helium in it? Oh, I'm not seeing a corresponding line there. And I'm not seeing a corresponding line there. And I'm not seeing some stuff. So I would say this star does not have helium in it. But what about hydrogen though? Oh yeah, look, they match up. They match up. So yes, we can quick look at these other ones. What about mercury? Not so much. It's got lines, but they're not exactly the same. And that's important. They have to match up exactly for them to be considered to be consistent. And then what about sodium? No, I'm not seeing any emission lines for sodium. So this star then is composed primarily right now of calcium and hydrogen. So what I can do is I can go back to my spreadsheet here, and what I'll do is I'll actually then bold those elements. So I'll do a double click, I'll do calcium, and I'll bold it, and then I'll also do hydrogen, and I'll bold it, and then maybe I'll italicize it too, so that way I know for sure. And then what about brightness? Well, if I come back here, I'm going to see that its brightness is moderate, so I can fill that information in. And then what about the temperature? Temperature's in K. Does anybody know what K stands for? Does anybody know what K stands for?
Kelvin.
Kelvin, that is absolutely correct. So we've got Celsius, Fahrenheit, and Kelvin. Those are the three ways that we usually think about when we're dealing with temperatures. Fahrenheit, you're the most familiar with. That's like the Americanized version, right? Americans, we're going to use Fahrenheit. Celsius is pretty much everybody else in the world. So Celsius is going to be a measurement of temperature that everybody else is. Room temperature in Celsius is about 25 degrees C, which is roughly about 70 degrees Fahrenheit. And then also like 32 degrees Fahrenheit is equal to about 0 degrees Celsius. Kelvin is going to be a temperature scale that's kind of like absolute. And it's kind of based on the molecular movement of molecules. So we have this idea of absolute zero, where we have no movement of the molecules, where we've reached a temperature where there's basically no thermal movement. It's almost impossible theoretically to get down to, but it's what we use as the temperature scale when we're talking about space. So a lot of stuff in space, we're going to be using Kelvin as our temperature scale. So this one is about 6,200 K. So I'm going to put that there, 6,200. Now, spectral class letter. All right, how do we figure that? Spectral classes. Ooh, did you hear that? Yeah, some of these have some really fun sound effects as they go through. This temperature is 6,200, which means that this falls in the range from 6,000 to 75. And then it actually tells us a little bit about what we should expect. So calcium and hydrogen, hey, that's kind of what we got, right? So its spectral type is F. So we can come back here and do that. We'll get to this in just a second. Let's see about the star color though. Can we get that information yet with any of this stuff? No. All right. So I'm going to grab this and I can pull it down here. This is that HR diagram. And we can basically say falls to the left, falls to the middle, or falls to the right. And so what we've got is, would it make sense for me to put that there? Well, the brightness is 62K, 6,200K. So probably not, right? Because if we go down here to the graph, this is really corresponding to something that's in between 15,000 and 20. So that should be about 18,000, which is off for our star. So that's not the correct place to put it. If I come down here and put it here, that's more like 10,000. So that's not really correct either. What about this one right here? Maybe that one's close, right? We said 6,200. This is like 6,000-ish. So maybe it's right there. Let's check it.
Check the element spectra to determine the spectral class of this star. Then try placing it in the HR diagram again.
I think that was a big womp, 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 womp. So it's like, nope, doesn't go there either, right? So what we're going to do then is I'll move it down here. I think that this one is correct. Let's check it. Booyah. All right. So we've placed it in the diagram. It doesn't fall in the middle. It falls a little bit on the right side, and this is the left. So you can make your own judgment on what you want to put in there for the HR position. But look, it's kind of like an orangish red. So then I'm going to put orange/red. And then I'm going to say, right, left. That's what I'm going to put. You don't have to put that, but you can come up with your own two for that. So then I've got that information for the first star done. So I'm going to come back here and I'm going to look at the second star. This is a different line. So we're going to go through and then we can kind of compare and see what matches up. Oh, no, this one looks like it's got some calcium, but then it also has other lines that correspond to other things as well. So then what you're going to be doing is you're basically going to be filling out this chart with the stars that you have. Now, why is this stuff so cool? Okay, so why is this stuff so cool? This stuff is so cool because if we can tell what the star is made up of, that means that we can actually tell how old the star is, because stars go through a life cycle. They start off with hydrogen. Big balls, massive balls of burning gas, right? Timon and Pumbaa, you can think of the Lion King, right? Up in the sky. And what happens is that they collapse under their own weight. So you've got gravity that pulls them together and it condenses and packs them in. And then eventually what's going to happen is that that weight is going to cause heat. And then eventually that heat is going to cause ignition. And you're going to end up with basically a star. And that star is going to be putting off energy. When we take hydrogen and put them with other hydrogen, we make helium. And then that helium can be made into other things. We can't really do that on Earth because it requires an insane amount of heat and an insane amount of pressure. And we just the amount of energy that it takes for that, we can't really generate that very well on Earth. But in the heart of a star is another thing entirely. You guys ever heard this concept before of you are stardust? Have you ever heard of this before? So when we think of the idea of a star and its life, what's going to happen is that we're going to be making all of these different elements. And eventually what will happen is that the star will go through a point in time where it either will collapse and then explode. There's some other stuff that they can do depending on what they're made of. But a majority of like what we think of for the stars that make up the stuff that we consist of, they'll collapse down and then they'll explode. Boom! And they'll blow these elements off into space that then condense into planets. And then we start this process, hopefully, with life. So when we say that you're made of the schnapps, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, a lot of those elements were actually made in the heart of a star. So when we have this idea that you are stardust, we are saying that the elements that make up your body right now actually formed in the heart of a star a long time ago. So that's the trippy part of it. When we say that you are stardust, we are literally meaning you come from the stars in that sense. And then if you want to get an even crazier level than that, I like to use the movie Inception. You guys ever seen the movie Inception? By now it's probably so old that like it's probably like considered like a classic or something like that. It's a really old movie that deals with dream states where they're literally putting people into dreams within dreams within dreams. And so I like to refer to concepts as being levels of inception. So level 1 inception when it comes to the stardust is just understanding that the elements that make up you came from the heart of stars. If we want to go another level down, then we get to the point that the pieces that actually make up those elements kind of existed at the very beginning, at the very Big Bang. So parts of you that make up the actual elements, that make up your body and your brain and all of the things that you are, were actually present at the Big Bang. So if you want to think about it, you, in some way, shape, or form, were present at the Big Bang. Yeah, exactly, right? Hopefully that got somebody. It says, does the bottom correlate color? Yes, bottom does correlate to color. And so when we think about what we're made of in these stars, it kind of gives us an idea of age, which then gives us an idea of where the star is in its lifetime, which is like totally crazy because we can pull that information just from looking at the light that comes from the star. We can tell what it's made of, we can tell how old it is, and then if we can tell what it's made of and how old it is, we can basically guesstimate how much it's got left. And there's a lot of information that we can pull from all this. And this is part of the power of physics and astronomy, as making those models and then doing the predictive stuff so that we can understand what's happened in the past so that we can predict the future. That's really kind of the goal of physics, is to understand that. Okay. So I think I short circuited. Nice. All right. Well, check that on my list. Short circuit one person today. So, you know, that's why I love these big picture types of things. We can get down into the nitty gritty and we can talk about spectra and stuff like that. But I also want you to consider the big picture when we talk about stuff like this. You know, where do these stars come from? What does that mean for us? For us that are on this planet right now, it means that our star is about halfway through its life cycle, which means that it's only got about 4 billion years left. And really what's going to happen with our star is it's going to increase in size, which is going to change things on our planet. So we really only got about 50,000 years left before things start getting really kind of like inhospitable and we're not going to be able to be here anymore. We got 50,000 years to get off the earth before things just not going to work anymore. Life as we know it, as far as like microbes and other types of like microorganisms, probably got about 100,000 years. So they're going to be able to weather the storm a little bit better of what's coming. But eventually the sun is actually going to increase in size and it's going to swallow up like the first 4 planets. So we literally are going to get sucked up into the sun. It's going to increase in size. And then if I remember correctly about our sun, and you'll have to fact check me on this because you got to do a little bit of research on this, it's going to get bigger and then it's going to condense down. And then I think it is actually capable of going supernova. So boom, so it's going to blow out stuff into the universe again. So, you know, nothing lasts forever except for the stuff that makes up the stuff that you're made of, if you can understand that. So we can find all this information out about the stars and really, let me go back to it. What I want you to do is kind of work your way through this, get those colors, put the stars on the chart, get all this information. And then I've got some questions for you. So the first question is, what is the brightness, temperature, and the spectral class letter of the sun? So I want you to pull a little bit of information about our own sun so you can kind of get some idea of what we're dealing with within our own universe here. And then it says, do a little Googling. What is meant by the term Goldilocks zone? So you guys remember the story about Goldilocks, right? Actually, I don't really remember the story of Goldilocks. I think that she's like, what, jumping in beds and like eating porridge or something like that. Is there any more to it, or is it just those two things? I don't remember. But basically, she's like, Goldilocks is a B&E, all right? So she's breaking and entering, and she's messing with everybody's stuff, okay? And we refer to this Goldilocks zone. It has to do with the distance that a planet is from a particular star. That's what I want you guys, you know, if you're needing help with that, that's kind of like what it's like. But I want you to Google it. I want you to come up with, you know, what do you mean by this Goldilocks zone? Can you find out about it? And then how does that refer to it? It has something to do with planets, all right? And then number 2, it says, would you say it's possible that all stars have a Goldilocks zone? Why or why not? Explain. So think about the stuff that we talked about. Think about the things that you're finding out through your virtual lab, and then you're Googling. And then I want you to kind of pull that information together, and I want you to come up with this. This is what you're giving me on your own, in your own head on this. Do you think it is possible or impossible that all stars would be capable of having a Goldilocks zone? Maybe they're not. Maybe they are. I want to know what you guys think. So I want you to kind of explain out your answer a little bit. You know, and don't overthink this one. I just want you to put a little paragraph there, you know, some sentences together as to what your mind is thinking on this one, okay? And so I want you to answer those 3 questions, and I want you to fill out this chart, and then you got the virtual lab to work on. And then we'll kind of discuss this a little bit, and then I'll be introducing you guys to the new thing that we're going to be doing next week, okay? And keep your eye open on the classroom. Now that I've got an idea of where you want to go and what we're going to be doing this semester, I can start putting some stuff up into the Google Classroom, so that way we don't have to just meet, like you can get a little prep beforehand. You can read up on it. You can kind of see what we're going to be going, what direction we're taking. And these first couple of labs, I really didn't know what you guys were all going to pick. And so they're kind of a little generic. Like these are just virtual labs that I pulled together that kind of relate to the things that we want to do. So we're going to get a little bit more specialized now that I know what your interests are. And that's going to be the basis for the summer, for the semester. So we're going to have a little bit of homework that you're going to have to do every week. We're going to have some projects that we can do, and I'm going to have some experimentation. I've got some experiments that we can do. We can kind of do some design stuff. I've got a little bit of some design things. I've got a little 3D printer with a webcam set up for that. And so we can have some 3D prints that you guys are making. I'm going to be setting up another one, so that way we can do multiple prints. We'll see how that works out. I've got some plants we can do. We can do some, there's lots of actual live streaming stuff that we can kind of pull into. So we can grab some live stream cams and kind of check out some information about space, but then also plants and animals and all kinds of cool stuff. So we'll be taking a look at that as well. And then, just lots of stuff. So this first week is more about just introduction, get an idea of what I'm like and what you guys are interested in, because I want to play off of that, because I know it's the summertime and I know that this is already kind of difficult with Zooming and everything like that. So if I can find stuff that you're actually interested in, then we can do that. We can do some fun stuff. So I would say that we'll go ahead and stop here for today. I'm going to let you out just a little bit early. What is it, 5 minutes? I'll let you out 5 minutes early, and I'll let you go to work on that. And like we said, if anybody needs any help with enabling the Flash on your browser, go ahead and stick around, and the UB members will help you guys out with that. So thanks so much, everybody. It was really nice to meet you, and I'm sure that I'm going to be seeing more of you as we go forward. So thanks, everybody. I'll talk to you later. Peace.